All right, this is the solutions video for homework 1.3b, page 64, and we're going to do 6 problems, starting with number 37. So we take the limit as x approaches -1 of x squared minus 1 over x plus 1. If you plug in a -1, you're going to get 0 over 0, indeterminate form. So we're going to need to algebraically manipulate this to see if we can get an answer. So the numerator looks like the difference of two perfect squares. So let's factor that into x plus 1 and x minus 1. You FOIL that back out, you'll get x squared minus 1 over x plus 1. Now we can cancel out the x plus 1 as long as x does not equal -1, because that makes the denominator 0. You must put that. So this would be the limit as x approaches -1 of x minus 1. And now we're going to plug in -1. -1 minus 1 would give us an answer of -2. All right, great. Number 38. 38, we have the limit as x approaches -1 of 2x squared minus x minus 3 over x plus 1. Once again, the first thing to do is plug in. If we do that, we end up with a 0 over 0, so we need to manipulate this. We've got a second order trinomial on top, so I'm going to try to factor that, and I'm going to use the clue that probably one of the factors needs to be x plus 1, otherwise the denominator won't cancel out. So I'm just going to go ahead and put that up there. So we've got a 2x, all right, 2x squared. I'm kind of thinking maybe a let's see, maybe a -3, because we need a 3 on the end, and that'd give us -3. So that'd be -3x for the inner, +2x for the outer. That'd give us -x when we FOIL it out. So we can cross out x plus 1 as long as x does not equal -1. That's the limit as x approaches -1 of 2x minus 3. We can now plug in -1, so that'd be -2 minus 3, which is -5. Boom. All right, number 41. We've got the limit as x approaches 5 of x minus 5 over x squared minus 25. All right, I can recognize that as the difference of two perfect squares. So we would have the limit. And if you plug in 5, of course, you're going to get 0 over 0. You want to do that first. As x approaches 5 of x minus 5 over x plus 5 times x minus 5. Conveniently, the x minus 5 cancels as long as x does not equal 5. That would make it a 0. So now we have the limit as x approaches 5 of 1. Remember, the denominator doesn't go away. It's just a 1 now, over x plus 5. And we can plug in our 5 for x, and we have 1 over 10. All right. Brilliant. Okay, I think we can probably fit 43 in here. We've got the limit as x approaches 1, x squared plus x minus 2 over x squared minus 1. So I recognize the denominator as the difference of two perfect squares. If we plug in a 1, we're going to get a 0 on bottom, and we'll be 0 on top as well. So we need, this is not direct substitution, so we're going to have to algebraically manipulate. Factor the top, factor the bottom. The bottom is easy. It's going to be x plus 1 times x minus 1. All right, on the top, I've got an x and an x. I'm thinking plus 2 minus 1. That give me a positive x in the middle and a negative 2 on the end. So now we can cross out x minus 1 as long as x does not equal 1. So that's going to be the limit as x approaches 1 of x plus 2 over x plus 1. Now we can plug in. We're not going to get a 0 over 0. That's going to be 3 over 2. Brilliant. All right, that does 4 of our 6 homework problems. I'm going to go ahead and erase this. Two more to go. They've got radicals in them, so we might be doing a little bit of rationalization on these two. So number 44, we want the limit as x approaches 0 of the square root of 2 plus x minus the square root of 2 over x. So if you plug in 0, you're going to get 0 over 0. So I'm going to want to go ahead and see if I can clear those radicals by multiplying by the conjugate. So the conjugate would be 2 plus x plus the square root of 2 over root 2 plus x plus the square root of 2. That's your clever version of 1. All right, so after we FOIL that out, and on this one, probably on the next one I won't show this, but I'll show everything on this one. The first term, 2 plus x. The outer term would be plus root 2 times root 2 plus x, and then the inner term minus root 2 times root 2 plus x, and then negative root 2 times positive root 2 would just be minus 2. And then I'm just gonna write this as x times root 2 plus x plus root 2 because I'm hoping that x will cancel out in the end. All right, almost everything cancels out here. That was the whole point. The 2, the negative 2, that term and that term with negative cancel out. All that's left is x. Remember to write the limit every time. So I'd have x on top, x times root 2 plus x plus root 2. On the bottom, we can cancel out that x over x as long as x does not equal 0. We'll have the limit as x approaches 0 of 1 over root 2 plus x plus root 2. Now we can plug in. You're not going to get 0 over 0 because the denominator is 1. That would be root 2 plus root 2. You've got 2 root 2's there, so we can rewrite that as 1 over 2 times the square root of 2. I am fine with that. Some teachers may make you rationalize that. So if you had to rationalize it, you multiply it by root 2 over root 2 to lift that radical. And that's going to be root 2 over root 2 times root 2 is 2 times 2 is 4. So the back of the book may go there or it may go there. I'm fine either place. Okay, let's do one more. Number 45. Got the limit as x approaches 0 of root 3 plus x minus root 3 over x. Now, this is very similar to the last one. It just changes root. We change a 2 for a 3 here. So probably I shouldn't have assigned this one, but we're going to end up with a similar answer, right? It's just going to have 3's in it. If you plug in 0, you're going to end up getting 0 over 0. So let's multiply by the conjugate, root 3 plus x plus root 3 over root 3 plus x plus root 3. That's just 1. Multiply those out, FOIL out the top, and you'd end up having 3 plus x because the radicals lift. The inner and the outer function cancel, and then root 3 times root 3 is 3, so you'd have minus 3. So in the previous question, 44, I wrote all that out. This time, since it's so similar, I'm not going to write it all out. Then we have x times root 3 plus x plus root 3. So the 3, the negative 3 cancel. X on top, x times root 3 plus x plus root 3. X over x cancels as long as x doesn't equal 0. We have the limit as x approaches 0 of 1 over root 3 plus x plus root 3. Can plug in a 0 here, and you have 1 over root 3 plus root 3. That's 1 over 2 times root 3, because there's 2 of them. And that is totally fine with me. If you were to rationalize, you multiply by root 3 over root 3, and you get root 3 over 6. So either one is fine. That does it for this homework. On the next homework, we'll use some of those compound fraction techniques and factoring perfect cubes, all that kind of stuff. So see you then.